Python programming language is one of the most important tool when it comes to the world of machine learning. Because it is widely used, it has a lot of support to support in terms of the functions, and it also has a very good amount of libraries available, right? Whatever we think we want to do, yes, it supports. There is a facility, okay? Something is already available so that you don't have to write everything from scratch, right? You should know that where is it available. I just want to take, say, I want to have I have a column of data. I want to perform something with the column, right? Which is a function you may not know. That's okay. That's absolutely fine. But you should have an idea that, okay, maybe there is a library like this. Inside this library, I may get a support for that. So those are the requirements we have. But before that, we should know, we should be able to recall each and every basic feature related to the Python itself, right? Since you already had a subject Python in your curriculum, right? This becomes very easy for you so that we can go ahead faster in today's session and maybe we can save some time. All right. Right. So basically, the Python is called as a interpreted language, right? So there is an interpreter, whichever program we write, okay, that will be executed one statement at a time. So I may have 100 lines of code, but the programs will be running in interpreted time. So one line, it will run, get an answer, use that answer for the next line, execute, and so on. Though you have written 100 lines of program, or you can run the code line by line on any particular command screen, right? So as already known, there are two fundamental what you call options you have. One is to use a collab, right? So directly, if you have a good network, good internet available on your side, you can go with the Google Colab, right? There itself you can run the code. Okay. So now also I suggest, if you have a good internet, yes, open the Colab and work with me. Whatever I'm typing here, you also type, you also check. Any doubt you have, you can ask me. Okay. So that's the first step. Okay. First option you have. The second option is what you can see on my screen, right? This is actually a Jupyter network. Right. So it's a Jupyter editor, right? It actually opens in the same, if you have a Google Chrome with you or whichever is your browser, this is also going to open in the same browser, right? But you need to install this beforehand. You cannot simply go to a website like Google Colab and you cannot start writing it over there. You need an installation, right? So the installation happens through again, multiple ways are there. So I suggest to go with the Anaconda Navigator, right? So refer to the pre-reading material which I have provided, right, already, right? The first few steps are there which you can follow, that actually talks about the installation of the Anaconda Navigator, right? So I have given a what you call as the link, right? This is the link which you can use to download the Anaconda. Right, you need to download a particular file. Downloads comes into your PC. It's an executable file. Double click on that. It will ask where I should install. Normal installation procedure, right? It will install in your system. And once you install that, right, there will be a Jupyter, right, written on your desktop saying that, okay, this is where you can. This is the icon which you are supposed to use. Okay, simply double click on the Jupyter icon that comes in your desktop after the installation, right? You can simply click on that, right? It actually opens up, right? So you see whatever the window that you are seeing over here is because of that double click on over there and creating a new file. Okay, there is an option to create a new file. Actually, if you see the reference material which I have provided, right? You have the complete details step by step. Just follow that and install, right? This is alternative option. If you have good computer, a faster computing capability, etc., you have enough computing ability. You don't have to depend on others like Google or someone else, right? You don't even need to have the super fast internet or something like that, which the collab expects. All right, so it's left to you what you want to do, right? What you want to use, right? Whichever you are fine, you can, right? Go with. So I suggest, my preference is Jupyter, right? Whenever it comes to writing the program related to ML, artificial intelligence, DL, data science, etc., right? Because everything is in my system, right? And I'm running and everything on my computer itself. This is what I prefer, so I'm using this. You are free to use anything you. Okay, so those who want the installation procedure, just refer to the material I gave as a pre-reading material, and it has already been added to the particular folder, right? yesterday itself. Okay, so fine. So you see here, whatever we see here, there is a in, right? Open bracket, close bracket, and you have written the line number 1 here. So this is a place where we write. Okay, whenever you open a new notebook, right, it can be, right, in the Google Colab, it can be in the Jupyter, right? So what exactly is going to happen is it opens up a new page like this, and you will be able to write the program in the form of cells. So this green color boundary, whatever you see, is it's actually saying that this is the cell where you can write the commands, where you can write the code. All right, so that's the first thing. Now I want to start with the first command itself, right? There is a simple command called print, right? So this is used to, if you want to see something on the screen, you ask uh, the computer to print something for you, right? So I will just write welcome to machine learning program. All right, so then you have two options to run. You can see here there is a run command, right? But every time when you're writing a larger program and coming back to this using a mouse and coming here and clicking on the run is difficult, right? So the other option is that you can use the same computer keyboard to run this and create a new cell, right? That is Alt and Enter. Okay, so you see Alt Enter, you see it actually printed something and a new cell has been created for you, so you can keep writing. All right, so this is the first option. It's left to you, whatever you prefer you can. All right, so now as and when you install, right, and you start working, there are you can see that there are multiple versions of Python available. So the most famous version, which was the previous version, was Python 2, and nowadays we are using Python 3. Okay, there are significant differences between Python 2 and 3, but anyway we are not going to touch Python 2 at all, because you can consider that as outdated version. So we will never consider that for the time being. We will be looking at directly the Python 3, right? So you can check the Python version in this way. So whichever version you are running, even on the Colab, you can check that. Okay, so this is Python, give a space, then dash dash version. So you see, right? My system is currently running 3.8.1, right? So this is a version. This is how you can check, right? Okay, now the very important thing first, right? Because whatever course you may attend, whichever textbook you may refer for learning the concepts, right? So in that, whichever material you have, right? So that may not be containing the complete information about the. So this is obvious, because there is a page restriction for textbooks. Whichever material you may use in the internet, they might not have covered everything. So where do you find out each and every details that is required for you to do the program? Right? Whatever I provide you as a material is actually an abstract material. In the sense, I may not be able to go in very detail, right, about this. I may just say that, okay, there is something called as list. List is entered in this fashion. List may be used for these applications, and these are the some of the few example codes of using the list. This is what the level I teach. Okay, because of, again, the time restriction, we may not be able to go in pretty much detail. But there is one location you can use. You can go ahead and you can obtain what you call as a help. Okay, this is called as a Python documentation. So I'm actually typing this. Okay, so this is where you get the documentation, out of which I'll actually directly paste the link in the chat box so that you can refer that. Please save this link with you, right? Everyone, please look at your chat box. There you can see a link that is being pasted, right? So click on that, go to that site and see the details present over there. On the top of, when you open this link, on the top you have a particular field where the version of the MATLAB, which is a version of the Python which you are using, should be selected. Okay, so 3.8 means 3.8, 3.9, 3.9. Depending upon your version, you can select the that first, so that corresponding documentation opens up. All right, so please use it. Keep this reference ready with you. All right, so this is pretty much important. Every detail that you want is present over there. So in addition to this Python documentation, you also have another help that is actually called as the standard library. Okay, so this standard library can be accessed using another link, right? What standard library functions that are present in Python, you can actually access them directly if you use the following link. All right, sorry, I just let me copy that once again. And all right, so let's see this. This is the standard library. I'm pasting this link also in the chat box. All right, so that actually gives you the direct access to the various libraries and the functions present, right, by default in your version. Again, you can see here, this actually talks about 3.9. You can select the particular version from the top. Okay, right. This is one method where you get the complete details. So inside after going there, you may have to search a bit to, right, find the proper function which you want to find. Okay, so that's what is a fundamental requirement as of now. But there is another method, right? I can get a I can actually try to find out the help, right? It is a shorthand help for accessing the various the various commands that are present over there. For example, there is what is called as a len, len, right? You know that if I write len, it is going to generate the it's going to find out the length of any object which you pass over there. So how do I know that what it is going to do, right? If you know the function's name and you don't know its help, you don't know what it is doing, right? In such case, just type that function and write a question mark after that. Right? So len, this is my function. I write a question mark after that, then run it. Okay, run that particular cell. So you see at the bottom, actually, I'm getting a help. Length of object, return the number of items inside that, right? It is going to call that as a container, right? Whatever you wrote here, right? The object which you pass, if it is x, length of x, so x may be a list, its length will be provided to that. Okay, so that's one thing. I'll show you something more about this, right? It's not just available for this, it is also available for the objects to work like this. For example, let me create a list. My list is equal to, as you know, right, this is the simplest data format which you can create here 1 2 3 4 5 6 7. Let me create this. All right, so it creates a list, my list. Now you see, in my list I can actually do a lot of operations. For example, there is mylist dot append, right? Append, what append is going to do, if you don't know what you do, mylist dot append, then write a question, right? Check this. So you see mylist dot append, in the bracket there is it says that there is an object, right? Append the object to the end of the list, right? I can actually add the elements, add few elements to the end of this list by using append, right? Again, we are not discussing about append now. I'm telling you how to get the help, right? So this is one very important thing that you need to remember. Okay, in addition to that, I don't know what is mylist. Again, mylist, you see, it's not a function, it is a variable which I have created. Do you get any help for that? So the answer is yes. See, it says what is mylist, right? It's a list of this format, length is equal to this much, etc. You get a details. If you require, if you see a variable, right, in somebody else has written a program for you, right, and you don't know what is that particular variable, what it contains, right? So it's simply, you can get a help in this particular fashion. So help can be obtained in various what you call, various ways, right? So you can use it, you can access that using various other types as well. Okay, right. Then let's go to a different thing, right? So there is what is called as a completion. I don't know what is the exact command to be written. For example, let me say LE and I type a tab, right? So tab key is the one which actually suggests what are the options you have, right? So for example, I just write L and I write tab. You see, these are the various options you have starting from L, right? So how do I know which function I'm supposed to use, right? The commands or the keywords in the Python are pretty similar to English, so that whoever has a basic knowledge of English can identify, okay, this could be the particular command which I'm supposed to use if I want to find the length. So length, license, you can see you type different letters and you check that. Okay, so I'm going for length, right? LEN for length, right? So that's how I check, right? Now I'll show you another one. So my list, I already have a my list, right? Dot, right? Let me say I don't know anything. What are the various functions, right? What are the various attributes this particular object has, right? So write an object name like my list, right? Put a dot over there, right? That's a period, and then enter the tab key, right? Every keyboard has a tab key. Press tab. You see, as soon as I press a tab, this is what comes up. You can see these are the options that are available. I knew that I had append, so I wrote append directly. But you don't know, you go with this, right? So these are the various, you can see that they're not many. They are very restricted, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Maximum 11 functions you can apply on this particular list, right? Individually, you can, right, select one, right? Say copy. Then you don't know what it is going to do. Put a question mark. This is going to give you the help, right? What exactly you are trying to, what exactly each function is going to do, you can check using the help, and what functions do exist over there, you can identify by using a tab key. So these are the very important, right, points you need to remember. You need to use it occasionally. Okay, so this is what I expect. That's why I'm taking time over here. Okay, so fine, right? That's what, right? So that's what is the first part. Okay, then, right, normally, right, whenever you start writing the codes, right, you need to import something, right? Everything is not directly available, right? You need to import the libraries. So for importing also, you use the same technique, right? Import, right? Just let me assume that I want to bring something related to math. I don't know what is the particular keyword, but at least let me write M there. Then I press a tab. So you see, right, the M, as soon as I enter M and I press a tab, it suggests, okay, these are the various libraries which you can import, right? So that's how, that's the first option. You know something, you know a part of the keyword which I'm supposed to enter. If you know that, yes. Okay. If you don't know that, still we don't have any problem. Simply enter a tab. Sorry, simply enter a tab. But now you have a lot of options to go through to select the one which you want. Okay, only that's the difference. So you can see that a lot of libraries are available, right? So, right, that's why initially I told you need to have an idea that, okay, this function might be present in a particular library, which I should have some idea. Okay, how it comes, how do you get to know? You have to keep referring the various, say, the links which I already have mentioned, right? Keep using them because that will give you some idea that, okay, this function is present inside this particular, you need to import this particular library for that. That comes again and again when you read these documentation. That's the first thing. The second thing is by practicing. You have to write enough code that, okay, so whenever you want to bring in something, you should be able to recall that, okay, that particular library is, that particular function is present inside a particular library. You will be able to, right, recall that. Okay, so those are the two important aspects, right? So one is to refer the documentation again and again so that that comes to your mind that, okay, this function is present inside a library like this. So library name should be there in your mind. And the second option, right, is to repeat the code, right? Write as many number of codes by yourself, bringing in many things, right? Just go to the website, some reference, take up a problem which is stated over there, try to solve by yourself. This has to be done. Okay, there is no way skipping this if you want to become an expert. Okay, so I highly recommend you to use it. All right, so that's another way anyway, right? Right, so this code, whatever I'm writing now, you will get this. Okay, this whole ipynp file, you will get it. Okay, you can run that file also on the collab if required, or you can run that directly on the Jupyter notebook on your system if required. Okay. Right, so that's how we have something like this. Then let's say there is another quick method, right? That is called as it's called as a matching. I want to match something. I don't know which is my what are the various commands that I have that matches to my word, because right, that pretty much important. Something like you use a star for that. Okay, star. Let me write warning, and I write a question mark. So if you simply write warning question mark, what happens? You get a help over. That is not I want to see how many various commands are there which matches to this warning, right? So you write a star in the beginning and then just, you see here. So this is the option, bytes warning, right? Right, future warning, import warning, many types of warning are there. Again, there is a single word called warning as well. So these are the various commands that actually sub matches to what you search. This is another way. This is actually called as a wildcard matching. The concept is called as wildcard matching. You can do that, right? So whenever I don't know what is the exact command to be used, right? I know half of that, but I don't have enough time to go through everything by using a tab and checking everything. So this is another option which I normally use. I find this, right, particular function very useful. Okay, that's why I suggest you also to use it as and when required. Okay, then again, this star can be used in a different way to find what are the various functions, right, available, right? So for example, str, it's actually a string, right? There are a string methods called find, but multiple, it may be present inside the string, it may not be present inside the string. So how do I come to know that, right? What are the find options available inside the string, right? I have to go for a star, then write whatever you want to search, like find, fine. Okay, finish that star indicating that, okay, between this star, whatever I have, I want machine to find out those functions and give it. So you have to tell that there is a question mark, right? In the sense, I'm asking a help from, right? So that is what is indicated by the question mark. Run that, you see that at the bottom, you see the result. str.find is one function, str.rfind is the other. Now what this does, right? If you are interested, you know how to find the search. Okay, go to the help, you check that what find does, what rfind does. Yes, you are free to go through that. And now you know that out of them, whichever is suitable for your requirement, you please use that. Okay, so that's how it goes. So now why we are taking so much time, because help is available in so many ways, right? So there is no question saying that I didn't know how to find out, right? So that's why this is very important, right? Nobody should should be, when we say why you didn't do that, right? You have to go for a reason which is something like, you cannot say that I don't know how to, because now we are dealing with everything, right? How to search something, how to find out something, how to get the details of what you have searched, etc. is available at the fingertip, right? One single step, you get the complete details of each and every function. What are the functions available also, I taught you how to find. Okay, so right, so that's very important thing, right? I want you to use this, right, proper. Okay, right, so then let's go further. Now another very important, let me create a x, right? So let me show you something. When you create a variable, you should know how to delete that as well. Okay, that's also very important. So I create x is equal to, so I'll create a text string. All right, so this is hello, right? Now you see x, if you simply write, you don't have to print every time to check that, right? You can simply write the variable name and press enter. It's actually you are trying to inspect. It's called as inspection, right? What is that x I can inspect? I don't have to print everything, but it looks very similar to you, like you are printing it out. Simply press that, it actually tells that x is hello. Right, now you see I'm teaching you how to delete, right? So this is delete, right, space x, right? Actually x gets deleted, no message is printed, but if you try to inspect what is x, it will tell that, right, there is an error now because x is not defined. Obvious, because I just erased that. Okay, so that's a very important part. All right, then let's move ahead, and let me show you something. What are the various inputs I have provided in this particular in this particular run of the code, right? So I'm writing code, and I already have written something like, say, 13 lines of code, let's say. Okay, in that, what are the various inputs I provided to the machine? You can check that. Okay, so that is print. Simply write in, or small n, I capital N small, enter. You see that these are the various inputs I have given to the machine so far. It actually is not in, right, not in a very neat format, but you will be able to trace it out. Okay, so you see, first I told, right, print welcome to this. Then I told something else, how to check the Python version, right? Then I created a my list, right? Many various things, whichever I did, I can see that. Okay, this is the first method to check, right, what are the inputs you have provided to this program, right? The next option is, when I give input, I should know how to check output. So this is OUT. Don't print, simply give out. You just have to, and this, so right, so far only one output. Machine has given only one output, that is equal to hello, right? Right, now let me go to a different scenario, that how do I check a particular input or particular output. Okay, so this is how you do that. So if you try to write in, I have given so many inputs, right? I check in one. Okay, in one, in the case, what is my first input? I just want to check. Okay, so let's check that, right? So this is what was my first input. Like that, even in the out, you can check that, but mostly I don't have in this case, I may not have multiple outputs available, but simply I'll just show you out of one. Oh, out one does not exist because out zero is there, right? So, right, so you understand that out one is not there. That's because index starts from zero in Python, right? So out zero. Oh, out zero is also not there. Why so? Let me check. Let me check. Let's see. error 0. Only one output that is present. We already have printed out. Because of that, it is not available. Out, let me check again. So, okay, out is there. Okay, let me tell you something else. Okay, so out, check that where you actually had printed that hello, right? Hello was printed at 11. Okay, so that was my mistake, right? I'm supposed to check that 11 only when I enter. I'll be able to see that. Okay, so just see here. So I have only two options to enter. I cannot enter 0, I cannot enter 1. I have to enter the specific output line, that is 11 and 16. So just see here, right? 16 is saying that this is my output, 11 says that this is my output. Okay, so just go back, just type out, in brackets you write 11, you see, you get that, right? So similarly, there is another way, right? Out 16 will give you the second print. Okay, I'm not going to do that. Then let's check the what is the most recent output, right? So I think this should work. It was there in the Python older version. Yeah, so 1 underscore prints the most recent output. Okay, similarly 2 underscores will enter the second most recent. So second most recent is the same thing, right? So this is the second most, so it's printing like that. So it's another way to check, right? The double underscore for the last second output if you want to print that once again, right? So underscore is also possible. So out can be replaced by underscore once again. Out at 16. Oh, 16 is not there now. So what happened? Should come, right? So let me try 11. String index is out of the range. 17. Let me check. So underscore, let me write 11. Okay, I should not write a bracket. That's my mistake. Let me write simply 60. Yeah, yes. So don't write a this thing. Okay, square bracket over there. That's going to give you the right output that is available at a particular right line of the code. The line number is 16, which is what I'm referring to now. So I'm able to print that. Okay, so any doubts so far? Anything you want to ask? Please go ahead. Right. Otherwise, we'll proceed further. Okay, so that's good, right? You are understanding, right? Let's proceed further now, right? Let me try to write 3 plus 4, right? As you know, it prints out 7, right? But now you see there are some cases in which I don't want the output to be printed. You can suppress the output. So perform the same thing, 3 plus 4, but you just have to write a semicolon at the end. This is pretty much similar to, this concept is actually directly derived from the MATLAB, right? Maybe you are aware of MATLAB software. I think you might have a lab on that, I guess, right? So in that every line is ending with a semicolon, will not display the output, will suppress the output. So same concept here. So now you see, if you write 3 plus 4 with a semicolon, you are suppressing the output. Okay. Is it okay? Right. I hope that is fine. Then let's move further. Okay. So I'll go to another part like where we'll start with the basics of Python itself. So what we are discussing is something like something which is related to Python, but not the coding version of the Python. How to get a help, right? How to see the output, right? How to see the inputs you provide, etc. We discussed. We never started with the Python itself. Now this is the first step, right, of Python. So I'm going to call that. Okay, so I'm going to call that as the Python semantics. So what do you mean by Python semantics, right? The whole Python is a particular is pretty unique, right? Why I'm calling it unique? Because you see, right, whenever I start a loop, you don't have to start with a bracket saying that this is where the loop starts, this is where the loop ends. Absolutely not. It is not required. Okay. So you may have a question, then should I use some keyword, like, because if you go for a MATLAB or any other tools, right, where you need to say end, right? I start a for loop. I start a for loop here. I write a code, and at the end I have to write an end there. Okay. So we have a question here asking, okay, who's asking question? Vandana, yes, one. So can we use these help techniques on any Python IDE or exclusive only for Jupyter? Yes, so this is actually related to the IPython, right? Whatever tool I'm using, it's interactive Python, so it's a part of that. Okay, so most of the functions are supported in IPython. Okay, but there are some other IDEs which have understood the usage of these techniques which we are discussing now, right? They have understood that, okay, even we have to provide our users, right, with some of the functionalities like this. You will see that other IDEs are also supporting, but not with this much of functionality. Okay, you will find out maybe something around 50 to 70% of the features that you see in this IPython, right, are available even in the other IDEs, right? So that's why I never touched the other IDEs. I directly started with this because you get a lot of helpful features in this. Okay, hope that answers the question, right? All right. So I was discussing about the semantics. What is the general way of representing or writing a code? It is, right, called as a white space structure, right? So I'll just add another comment over here, right? So we use white space to structure our codes, right? This is very important. No brackets will be used saying that, okay, this is where the for loop starts, this is where it ends. No, you have to give appropriate white spaces. Spacing is very important. Okay, so just see this, right? I'm writing a function now. Okay, let me say I'm writing a function. Don't worry about a function, we are going to discuss that at a later stage, but I just have to show you the usage of the white space, right? So I have to write multiple lines of codes, right? So say def is a keyword to define something. I'm defining a function, right? So defining a function is done by def. Write the name of the function which you are trying to write. I'll say even or. I'm trying to find out a given input is even or odd. I'll just write a n, which is my input. Okay. So now you see I have to write a colon saying that, okay, my first line is over. Now you see, when I press enter, observe something. See, it started after a space, right? You can see there. Automatically this editor created a space for me. It's not a one space, it actually is a set of four spaces together. So four spaces are required when you want to say that something, I'm inside this, right? I'm inside a function. So inside the function means you have to, from the starting of the function, if I consider this line, right, below the D, after that I have to give four spaces to write, saying that, okay, I'm inside this particular function, right? Maybe, right? So I'll just go for a if condition, if n mod 2 equal, sorry, n mod 2 equal to 0, right? You see, this is the if condition. Inside I should go inside the if. Means what? You look at that, look at this carefully. As and I press enter, it goes again, it gives another four spaces, saying that I am inside the if condition. I am already inside the def, right? Define, right? I gave four space. Now you see I come out of this. So I go further inside. So I'll just say print, right, even. Okay, so this is done. Now I press enter, it is still inside that. I don't want to do. I want to say else condition. Else is not inside if, else is inside the def. So simply press once backspace. You observe it actually jumped, right? It understood that, okay, I have to go outside. So then I write else. Okay, so else, this is what happens, right? As soon as we press this else, I have to say that the other option. What is the other option? Print, Am I printing? Yes. Print all. Okay. Now you see, I come out, nothing happens. There is nothing. You don't have to. So in this case, my objective is not to return something. Whatever I pass, it will be printed here. No end, no bracket closing, nothing. Simply finish this. So I run this, it actually compiles. You can see that, right? It compiled and I got it. Now, how do you call this? You can call it as, right? Even or odd. Let me pass a number called 27. See, it's odd. Let me call it again. Even or odd, right? Let me say 100. It's even. That's all. You see, the function worked very simply. In a very simple fashion. You don't have to use bracket. You don't have to use some other keywords to say this is start, this is end. Nothing is required. Just take care of the spaces appropriately. It will do the required job. Okay. Whenever the spaces are not aligned, for example, let's see this. I'll copy that. I'll paste it here just to show you the error here. Okay. Whenever I do so, and let me say I'm not giving any spaces. Okay. So I'm actually making a mistake here. So you will see that this is what is going to happen. If you don't write with appropriate spaces and you enter, it does not understand. So it throws out an error saying that, no, I don't understand what you have written. You are not following the requirements, right? You are not following the Python language semantics, because of which machine does not understand. So C and other languages like Python, other languages like maybe the MATLAB have their own way, right? You don't have to worry about the spaces over there, but you can write like you have to use the brackets, so many number of brackets, you have so many number of keywords saying that this is where it ends, this is where it starts, many things you need to write. So that is actually avoided here. Simply look at the spaces required, right? Most of the time, if the IDE will take care of that, you don't have to worry. You see, I never worried about that. So what I did, I kept writing it in this way. So I went maybe as in this is where I go, I press enter. See, automatically it puts over there. You don't have to worry. So if condition I printed, see the print goes automatically to that position. You don't have to worry actually. Okay, but the semantics you should understand. If I want to go inside a particular block of the code, I have to give sufficient number of spaces at the beginning. It is fixed to 4 as a default. Okay, so we don't have to change it. You simply follow that. Okay, so that's about this. Now the next part is comment. Commenting is also very important. I highly recommend you to use the comments. So when you write a as symbol and followed by whatever you type will be considered as the comment. Okay, I'll show you. Right, you see it's not going to run. So I'll write say print. Let me write welcome, and after this I'll write a comment. Okay, so saying that this is comment. See, it runs only the print part. Other than after that, whatever you have, it's not going to consider that, because it identifies that after ash whatever you write, it's right. It's nothing but it is a comment. Okay. All right. So that's the first part. Okay, so we are starting with the Python, right? Python semantics. Understanding the Python semantics is pretty important, and we have done that. Okay, do we have any doubts with whatever we are discussing so far? Yes, please go ahead. Right, we are open for oral discussion, as well as any comments you want to make. You can put it in the chat, right, at any point of time. All right. Let's go ahead, and so the next thing is, right, we call it as a referencing. It's called as a dynamic referencing. All right, let me say what it is. So any object you create, right, there is no specific type that is associated with a variable that you create. For example, let me try to write a. Okay, so a is equal to, let me write, okay, a equal to 5. I know that 5 is a value that is present inside a variable called a. Right, now I'll ask, tell me the type. Again, right, we most of the time we don't look at the keyword separately, as in when it comes in an example you should understand from there. So you see the keyword here I'm using is a type. If I write type a, it tells you that it is int type. If you have a floating like 5.5, it will be showing that as a the float at that time. Okay, but now you see there is no rule saying that you have to store only int in A, right? So what I do, I'll write A. Okay, namaste, right? So now you see, now you check what is there in A. It's a string. Okay, so now you can see that whatever we are storing here is a string, right? So that means that's a concept of dynamic referencing. You can put anything into any variable. There is no restriction on that. Again, this may be a case, maybe in case of a C, right? You may have to declare that, okay, I'm using int in A, which means you cannot change it, correct? So that problem is not there. Just understand, right? So you don't have to declare I'm storing int in A, and then there is a then it puts a restriction over there saying that you cannot put a float into A. That problem is not there. Okay, right? But there is a restriction, right? The restriction comes into picture now. You see, I create B. B is equal to 10, and I'll say C is equal to, it's a character called D. Okay, or let me make it more clear here. So let me write another. You see the difference. B is a number. C is a C holds string. C is a character. Okay, so that's fine for us. Now you see what I do. I'll try to perform the B plus C. Right? There is no facility to do this because understand what's the problem. It says an error. It throws up an error saying that I cannot add an int to string. This restriction is still there. You cannot do this. Okay, so just understand what we did so far. Okay, so this is a restriction that we have. Okay, so unsupported operand plus for int and string. We cannot do this, right? It says that B plus C is not possible. Okay, but there is a facility to do this conversion. There is, it's now right now it says that one is int, one is a string, I cannot add. But you see now you see, I'll define A. Okay, A is equal to 10.95. Okay, this is a float, and I'll say B is equal to 6. Okay, this is created. Now you see, I'll try to do something like say A divided by B. Let's see, A by B. See, there is an answer, right? It is not throwing in any error now, because under these conditions, when both are you are able to perform an operation, whenever you convert one of them to the other case, like 6 is converted into 6.0, 6 is converted into float, right? If you do that, you have an answer, right? Meaningful answer. So in such cases, right, the Python does that change. Okay, type conversion will be possible under such case. But in the previous case, you see something is a number, integer, and the second one is a string, right? What do you do even after converting string into any other format? It's of no use to you. So that's why there you didn't had a conversion possible, but now yes, the conversion is possible, and right, it's actually right doing something for you. All right. All right. Now let's go for something which is slightly different, right? This is also pretty much useful, so I'm discussing something here. So the one first, arithmetic operations are directly supported. For example, you know this. I don't want to spend more time here. So 2 minus 5, it works, right? Directly it gives you an answer, right? So 10.99676, right? Plus 3.0094. You have an answer. Oh, sorry, my mistake. I gave a space in the middle. That's my mistake. Sorry. I should not give a space, right? You know that it gives you an answer. Absolutely fine for us, right? Now, what we need to remember is that it also supports the logical expressions as well. For example, the logical in the sense true or false. So 4 is less than or equal to 9, right? 4 is actually less than 9. So even I check the other condition. you see it says it is true. Okay, similarly 12 is greater than 15, it says false. So true or false is also supported in a very similar fashion, right? Just remember, right? Other options also there, like less than or equal to, right? Less than, not equal to, etc. You can check, right? I'm not touching everything because anyway, you know that, right? These are supported. One of them is supported, others will be definitely supported. Right. Now, there is what is called as uh, a keyword called is, right? I'll show you that now, because whenever you want to check whether multiple, what do you call, references are there, and you want to check that whether it's the same, you can use is keyword. For example, let me see. Let me say A is equal to, let me write 1, 2, 3, 4. Okay, A is equal to this. I'll say B is equal to A, sorry, B is equal to A. And now you see I'm using the E keyword. A is B. It says true because A and B are giving the reference to the same values 1, 2, 3. Okay, right? Now, fine. So that then we have another option, right? That is, okay, so let's go for something called as a mutable and immutable objects, right? Whenever we create something, right, there are something called as a mutable in the sense you can, once you create, you can change them, right? That is called as a mutable, right? So the objects, few of the objects which we create are mutable, right? So for example, let me create a list. Okay, so I'll say, I think I have my list already created. So you see my list is already created. I'm simply printing that. So if at all I write my list of 2. So 2 means 0, 1, 2. So the third element will be printed out. This is what is expected. So you see 3. Starting from 1, begin first position, 1, 2, 3. So third element will be printed out. Third element is 3. Fine. Now the objects are said to be mutable, right? In which you can change them, right? For example, I'll just try to write like my list of 2, change this to 300. I'm changing that. You see, if I try to print the my list now, you see 1, 2, 300. So something which was there already existing, its value I'm trying to change. If that changing is allowed, it is said to be mutable. You can mute it. You can ask that, hold on, something else I want to say, right? So that is a mutability, right? This is possible. So in case of Python, lists, dictionaries, n-dimensional arrays. So these are the 3 things which are commonly used. We are going to use them. Okay, that's why I'm talking only about those 3. One is a list, one is a dictionary, and one more is called as a ND array. ND array you might have not come across, but we are going to see that in soon future. Okay, so very soon we'll be using them. So I'm using the term now. N-dimensional array is called as ND array. So those are the mutable items. So don't worry about immutable items. There are something which we cannot change. We'll come to that. When we reach that, we will do it. So I want you to remember mutable, immutable. That was my idea here, right? So I just started with that. Okay. So I'll give an example of immutable. This is actually called as a tuple, right? You might have heard what is called as a tuple, right? So strings are immutable, right? If you write strings, you cannot change. Okay, so that's one thing. So let me create a tuple now. So my tuple, it's another representation, another data type that is supported. Okay, so let me write, say, right? I can write something like AA, comma, I can also write 6, 55, right? Then I'll write I can even put a list inside this. So 23, 67, this is fine. Okay, so if you write my tuple, it will print everything, right? But now you see, I'll try to change this. My tuple of 1. So what is this? This is actually 6. Now I'll try to change that. My tuple of 1 equal to, say I'll change it was actually 6, I'll put 9 over here. Okay, not equal to, sorry, my mistake. I'm checking that's actually a checking. I'm not checking that. My tuple of 1, this is what I want to. I want to replace that 6 by 9. Okay, right? Tuple is an object does not support, right? It is immutable object. Okay, tuple and strings are the most common ones which we will be using. That is going to be the immutable type. Okay, mutable, immutable. All right, very clear. Do you have any doubt with this? Okay, all right, let's go ahead. Right, I'll go to the various types that are supported. Numerical type, right? I think you already you are aware of that, right? I can try to let me show you something. Okay, int value, I create something like 1 2 3 4 5 6 7 8 9. Let me see. Okay, int value. Now you see, if you go to the other languages such as maybe the C programming, Java, etc., there is a maximum restriction. The highest number that you can represent, there is a restriction. I'll show you that is not there here. You can try with this and just write int whatever that I wrote, int value, right? I'll write the star. If you write together, it is a power. Okay, I'm raising that to a power. So something like x square, if you want, right? You write x into x star 2. That is x square. X star 10 is x to the power 10. Okay, so let me try to write something like this to the power 10. In the sense, this int value, whatever I have written, I want to raise it to the power 10. Right? C program, if you do something like this, it will throw up an error saying that no, I cannot calculate this. I don't have that much memory allocated. You see here, it gives an answer. Raise it to the power 100, you still get an answer. Right? There is no restriction. One very good feature, okay, of the Python. So that's why the Python can handle large numbers and the large size of data. So because of that, right, that's one advantage why we are preferring this for the machine learning, deep learning, right, data science, etc. Okay, so that's one very important feature. Okay, then we have say the float value. Already we have used the float. You can use it as a float, right? So float value, right? There is another representation. This is also important. Now you simply write float value is equal to, I can simply write to 16.35, something like this. I can enter. Okay, so that actually the float value, if you simply do this, it actually prints out whatever you have entered. But there is another method that is called as a double precision number, right? So those who are not able to recall what is a double precision number, I suggest you to go back, search in the internet and identify what it is. Okay, I'll give an example. At least that will help you out to understand something about it. Okay, so I'll write the float val 2 is equal to, I'll just write like this. So this is 19.3356 into, there is a e minus 80. Okay, right? Let me try to print this. The float value 2, right? You can see that it is actually representing, right, in the exponent form. E represents 10 to the power. Okay, so 1.93356 10 to the power minus 70. So this kind of representation is falling under what is called as a double precision number. Okay, so that is one way, right? But right, depends whether you want to use it or not. All right, but it is supported. It is very useful, right? I have another one to show you. That is 10 divided by 3. So I know that it's going to give an answer like 3.33333. But there is a method using which you can actually get only the integer part of your answer. Like 10 divided by 3 is 3 point something, right? I just want to eliminate the point something. I just want the whole part. So is it possible? So yes, that is possible. That is called as double division. Division, then you write 3 over there. Now you see the answer is 3. Okay, this is called as an integer value, right? You are trying to obtain the integer division, right? Obtaining answers of an integer answer after the division. Okay, sometimes you want to know only this. You don't have to worry about what comes after the decimal points. If such case you have, right, you can simply write it. Okay, so I hope that is fine. Any doubt with what we have been discussing so far? Fantastic. Okay, let's move further. So numerical data I discussed, whatever is very important. There are many more things. I expect you to go to the documentation and understand everything. At least go through them and try to recall that, okay, these are the things which do exist over. Okay, so I'll move further. I'll go to the strings part. Okay, so strings in the sense, right? Let's say I'll start with the string, right? So my str1 is equal to, so how do you enter a string? You can enter a string either using a single quotation mark, like, right? So this is a valid string. Okay, my string 2 is equal to, you see I use a double, right? Double quotation mark, then also this is valid. Okay, right? So both are valid. Okay, now the print actually works with multiple inputs also. I can simply say that print the, sorry, my string 1 comma my string 2, print both of them. Yes, you can see that it will print both of them. You can pass multiple variables to the print statement and multiple arguments to the print statement, it will print everything. Okay, so this I think I never mentioned earlier. This is valid. Okay, now you check the type once again. So you know that you can check a type of the my string 1 or 2. You can check, it says that it is a string. Okay, fine. Now there will be some cases where you are supposed to enter the strings in multiple lines, right? So that is also supported here. Just look at this. All right, so this is how we do that. So my string 3 is equal to, only condition is that you should use 3 single quotes or 3 times double quotes. Left to you, you can see that. So I'll just write Dhaarini space Academy of Technical Education. You see multiple lines are written here. So I can ask, I can just check the my string 3. So yes, you see that since there is a new line given, it actually prints out a new line character. Okay, if you check like this, it says new line character. You don't want that to be printed, simply go for print statement. Okay, so print the my string 3. Now you see it actually shows in this way, right? So that's the difference between printing and inspecting. So the previous one was the inspection, now you are printing. When you print it out, the new line character will be eliminated. Okay, so that is very important. Okay, and you see, as I mentioned earlier, the strings fall under immutable category. So I'll try to do that. Now you know that my string 3 is there. I'll try to do this thing. My string 3 of 2. The second character in that, I want to change this equal to, say, A. Okay, say A, right? It should throw an error saying that I cannot do that. Okay, so that's what happens here. Is it okay? Right. But you may have a problem with that now, right? Because Obviously, sometimes it comes, somebody has entered, there is a mistake in that. How do I correct? Right? It's needed, right? So there is an option here. Okay. So the option is, okay, called as a replace function. All right. So my string, okay, there is already a 3. I'll write so for 4 is equal to my string 3 in that one, right? Dot, it's called as a replace, right? I just have to tell what is there and what I want to replace it with what. Okay. I just want to say that, okay, there is a off in that. Let me say I want to correct that as off. See, this is what is the change I want. Okay. So, okay, I'll go for a print. My str code, right? So you see it actually changed now, right? You cannot change it in the same variable because my str3 is immutable. But now you see I'm not actually altering that. If you look at the print 3, right? See, it is still same. I actually, immutable means it is immutable only. I will never be, it will never allow you to change that. So, but what we did now, we created a different, right, variable in which whatever there was, whatever, wherever you had an off written over there in my string 3, I replaced that with the off. This is what was the command, right? So because of which, when you try to create a mystr4 from mystr3 by copying each and every element to that, it replaces the OF, right, by OFF. So that is very clearly visible in this particular example. Okay, so you want to make a correction, this is the only option you have. Okay, so hope that is fine. Right. So one of the very important feature is that you can convert anything into string, right? Because this is very important, right? So the usage we'll see later, right? Let me say I have a, what is that? There is a float value, right? Let me go for that. Yeah, this is a float value. Now you see, if I try to do something like, uh, it's a string of the float val, you see that I don't have single colons written around this, saying that it is a number. But now you see it actually has the, so initially and the last, at the last you have quotes, right? That actually comes up saying that it is a float value. It is not a number, it is a float. It's sorry, it is not a float value, it's not a number, it is a string, right? So 1 is a character, 6 is a character, point is a character, 3 is a character, and so on. Okay, so that's what, right? This is pretty much important, right? Usage we'll see later, but this is what I want you to remember and understand. Okay, right? So now whenever we have something like right, like this, we have a string, right? The string can be converted into various formats. Okay, so what are the various formats that we can convert? The first one is the list. Okay, I can convert something into list. Okay, so let me check, let me create something. My, do I have my string one? Let me check that. Okay, that is Dhaarini. And what is there in my string 2 also? Let me check. Okay, my str2 is this. Okay, so let me create something new now. My str, say 3 is equal to, right? You see here, there is an option called as simply doing an addition. Addition is possible here. The my str1 plus my str2. Okay, then I'll say print my str3. So you see, it actually, right, has performed what is called as a concatenation. String 1, right? String 1 is there, right? To that, I'm adding the string 2, it is a concatenation. So when you do plus, when you do the addition, in case of strings, both are strings means you can do addition, it is performing the concatenation. Simple, very simple. You don't have to write a long code for doing the string concatenation. Take a string plus another string. Now you see, I'll do this. I can also do this. So I'll just copy this. I'll just paste over here and sorry. Okay, let me go back. And now you see, I'll try to give a space here because that's a valid string, right? Then I say plus. You see? Okay, I need to print. Print my string 3. Now you see the space came in the middle. Previously, you see here, when I didn't give a space, right? Simply it concatenated to get me, right? Without space between the I and A of Dhaarini Academy. But now you see the I and A, between them, I have a space given because I said that use a my string 1 first, then give a space, then concatenate that with the next one. So this is possible. Very handy, very important. Okay. But the one which I wanted to tell you is this. I want to convert the string into a list. Okay. List of my str3. Just observe, right, the output. So it is a list. Every character has been separated it out. Okay, including the space. All right. So that's the first thing. And another very important part, I think you are aware of this. It is called as a slicing, right? So my string 3 of, so first whatever you write, it actually corresponds to, right, the starting position. You can write a starting position to the end position. I'd say starting, I don't write a number there. It means it is starting from the first, means 0th index till, so let me say Dhaarini. So that is actually 8, right? So I'll just write 8 over there. So see, it actually extracts only Dhaarini from the Dhaarini Academy, right? So this is what is called as a slicing, right? You can slice it out if required. Okay. Is that fine? I hope, right, you are understanding, right? You are trying to recall because everything should have been already been done to you because we are still at the basic level only, right? So I hope you are able to recall that. Is it fine? Any doubt you have, please go ahead. Otherwise, I'll move ahead. I'll move to the next part. Okay, right. So the next point of discussion will be related to the Boolean operations, right? So there are two Boolean values supported. One is called as a TRUE, right? So this is a true and false, true and false. So now we know that the various logics can be developed by using, right, the true and false. For example, true and is another keyword which identifies the and logic between them. So if I write true and false, I know that the answer is false. See, it comes up. Similarly, you can go for the right false or true. What is the answer? What do you expect? It's a true, right? So you just see this is going to happen, right? Simply you can apply, right? I can write some of the what you call uh, some expressions which evaluates to true or false, and I can use them to perform and or the various logics that are. Okay, so I'm going to give a material after today's session, right? That will contain whatever we have discussed so far and whatever we are going to discuss next. Everything will be there in very detail. Okay, right now we are not having much time to go through the each and every part of whatever we are discussing, right? So, right, I'm trying to give you an introduction. I'm trying to tell you that okay, this is what we need in our main course, right? So I'm trying to highlight what is very important only, right? But you will observe that the material which we will get today will contain a lot more than what we are discussing. Okay, so keep that as a reference and this coding file as just to see that whatever things we highlighted most, right? So keep both of them with you, right? This coding file will help you out identifying what is very important. Okay, so whatever is there in the file, that contains a lot more information than what we are discussing here. Okay, so fine. So let's go for an example and let's check this. Okay, so let me create A is equal to 12, say B is equal to 13. All right, then I'll write a print, but inside the print, I'm going to do some checking, something like A equal to B minus 1. This is what I want to print first. Then second one, A equal to B, right? Then I also want to check A not equal to B. Okay, then I want to check let A greater than B. Okay, let's print it. It says I'm checking that whether A is equal to B minus 1. Answer is true. I'm also asking that A equal to B in the second this thing. It says it is false. I'm also asking A not equal to B. That is true. I'm asking A greater than B. It says it is false. Right? So you can actually check like this. Right? But you see, there is a wonderful expression which supports you to check multiple things. A less than B less than 20. It is true, right? If something comes as false, it will simply print that as a false. Okay. Okay. Then the next numbers which we'll be using, the next type, Boolean is over, string is over, is a complex. The third one is pretty important. This is complex. Okay, so you can create, say Z is equal to 3 minus 4J. Okay, let me go with every detail. Print out something so that you will understand this. Okay, print Z for me. Print Z dot, I think we have called something called as real. Yes, Z dot real. Z dot, I can write image. Do you have image? Yes, you have image. You see, I didn't know what was the keyword. I just searched it out and I used it. Okay, that's what I meant when I told you, right? This is how you use it. So I can do this, and then I can write absolute value of the Z. Okay, I can actually print out all of them. I can also specify, go to a new line, that is use a separator. Separator is equal to \n. You know that \n is a new line character. So you see, answer comes line by line. So real part, the Z is printed as it is, then the real part, next line is imaginary part, then the absolute value. Everything you can use it in this particular fashion, right? You can also try to print out the multiplication, division, etc. Right? So you can do that. That also is supported. Let me create something like X is equal to. So this is, let me try to write, say 5 minus 12J. That's what is X. And let me print X plus Z, Z minus X. Okay, X into Z and Z by X. Let me give a separator here. Separator is equal to the same thing. All right, so that's the \n. Okay, yes, we have an answer. Is it okay? Right, I hope you are fine with this. All right, we'll take 2 more minutes for the next concept and then we'll go for a break. Okay, so the next thing is called as a typecasting, converting one type to other type. Very important. Okay, so you see, right, if I try to write 100, it is actually integer, right? But if I try to write float value of 100, observe the difference. You see, it actually adds a dot zeros, indicating that it is a float. Okay, right? So now you see, I'll try to convert this answer into a bool. Okay, so it's a boolean converter. Boolean value of 100 is true. Okay, but at the same time, if you use a boolean, okay, boolean value of 0, it is false. Let me check with a negative number just to make a conclusion at the end. All right, so that is Boolean value of, say, -10. That is true. So the indication is that only if you have a 0 over there, that Boolean value is a false. Any other number which you have there will be converted into a true. Okay, so Boolean is used to identify whether there is a number or not. 0 is right, 0 is nothing, 0 is saying that there is nothing, which will be converted into false. Anything else, 100, 100.5, 200, anything, -200, -2000, anything will be converted into true. But if you have only 0, that will be converted into false. Okay, so remember this, right? That actually, right, with that we are trying to cover up majority of the data types present over there. Few are left, right? We go for a break, take a 15 minutes break, come back at 4:15 and we'll resume the session from there. Welcome back, everyone. We'll continue from where we left. Okay. Before that, do you have any doubt with whatever we were discussing so far? Please let me know. Otherwise, I'll move to the next data type that is pretty useful to handle. Okay. So the next data is called as a data, it's a date time object. Okay, it's called as a date and time. If you want to use the date or the time as an object in your program, right? So you are supposed to bring it from a specific what you call the it's present inside a module called date time. All right, so remember this, from date time you're supposed to import, right? Either only date, if you want to use only date, right? I don't want to use any time over there, just a date, right? If you want to use, you go for a date. Then there is something called as a time, right? If you want to use only time for time, in a sense, it's actually hours, minutes, and seconds, right? That you want to use together, you have to do that. Okay. So then we can also do something called as say, you can club all of them together by using what is called as, it's a date time, right? All the three I'll bring. Okay, all the three I'll import. So by importing this, now you can use the date, time, and date. Okay, so the first thing here is, right, something like, let me create something like my date time. This is a variable. Okay, this is equal to, it's a date time. See the order in which I am supposed to enter. Okay, so that is the year first, 2022, followed by the month, right? Right now the month is 8, and the date today, 25. Now my clock is actually showing, right, the time as, say, 4:15. Oh, sorry, 4:17. 35. Okay, so daytime is created. Now you can check that, right, how this is actually being formed, and you can actually, right, look into this in detail by just typing my date time. So you see it's actually a date time format because date and time clubbed together, 2022, right, 8, 25, 4, 17, 15. So it's in the same order in which it has been entered. Okay, so you will be able to use this in the date time format itself whenever you want to, right, use it in any part of your code, saying that, okay, this is the date, this is the date time, etc. You want to use it, means yes, you can use it. Okay, so only the introduction I'm giving, right? Other part of this, how do you modify, how do you change, what are the various fields, what are the various functions that you can use in date time, you get the complete details in the material that you are going to get at the end of the day. All right, so please refer that, it's very important, but I'm skipping that and I'm going ahead. Okay, all right, let's move to the next part. This is very important, that is the control flow. When I write a program, how the control can be, right? How do you have, how do you apply certain logic to control uh, the flow of your program based on certain logic? It can be by using the say loops that are also valid. Okay, so everything we are going to see now. So the first one is the if else. Already we have seen that, but let me show this. Okay, so something like, I'll directly write an example. Okay, if this is a different approach. Okay, not the one which I used already. Def n, I'm passing n to this. N is a number which I pass. It has to say even or odd. Okay, so if n percentage 2 equal to 0, that means a return is something I calculate in a function and I return it back. The same return function, keyword we have used many times in many different programming languages. Okay, it's doing the same thing here. So that is return, right? I'll simply say 2. In the sense, yes, this is a even number. Okay, right? This is inside this. If it returns, if it is not going back from here, it means it is odd, right? I don't have to check the other case. I don't have to go for else. Simply return false. Okay, so let me check this. Even, oh, what was the name given? Both look very same. It's even or odd. Oh, I think the previous function was ever or odd. Okay, so this is even or odd. Okay, even or odd, I am passing the number, say 3. See, it says false because this is the one which returns. The return happens here because only when this is true, it comes inside this and comes out from this, saying that it is even function. Now, it actually, it will not go inside this. It will not go inside this means it will return this false. It is a odd one. So even or odd for 100. See, it is true because it initially checks that n% is to equal to 0. Yes, 100% is to equal to 0. So it will come inside this, it will directly return from there saying that it is true. So no false will be printed in such case. So this is one very important control flow. By simply using if, you don't have to even go for else condition. Okay, right? So that's how it is. Now let's go for another case here where if so, see the simple logic is very simple. I'll try to tell one very important hint here. Whenever the conditions that I'm going to check is just two, like yes or no, true, false, only that is my condition. Don't use else. Okay, if something come out of the if, return something else. Okay, don't go for else because right, else, no wrong. Even if you use else, no problem with that, but that is not needed. That's all, right? Why do you want to use another condition? It will spend some time over there to check the else and then going inside else, right? So save some time. Okay, this is the basic idea. I have just two answers here, like yes or no. I checked something. If that is not true, that means the other itself is the answer, so directly tell. But when you have more than two, like 3, 4, 5 or more condition to check, you have to go for what is called as else condition. Okay, so let me actually directly paste something from something so that I can save the printing time. Okay, so look at this code. I define a function called divisibility check and I pass a number n to that. So look at the first thing I compare. If n mod 3 equal to 0, in the sense if the number is divisible by 3, and so and means it is a logical function, this becomes true only when both sides of and results in true. In the sense, if number is divisible by 3 and the number is divisible by 5, I will print that yes, this is divisible by 5. Okay, that number whichever you pass. Next one, you see else, right? I'm not going for simply else, it is else if, because I have many more conditions to say. only number is divisible by 3, you see there is no number divisible by 5 after this. Only number is simply divisible by 3. I'll say that divisible by 3. Okay. Else if n percentage 5 equal to 0, I'm saying that return divisible by 5, right? Because it is only divisible by 5, not by 3. So if none of them is true, then go for else not divisible by 3 or 5 is what I'm saying. Okay, so let me run this. It's very straightforward, but I'm trying to demonstrate when there are multiple conditions like this. Okay, so divisibility check is the function. I'm going to check 6 first. Right? I know that it is only divisible by 3. So next I'm going to check divisibility by this by 10. So it's divisible by 5. Okay. So divisibility check I want to perform, say, for 30, right? I think both 10 and 5. That's all. Okay, so this is what, try to recall the if else condition, whichever other language you have studied, even in the Python you might have used. Try to go back, right? If there are some programs you already have written or some assignments given to you to solve, right, by yourself, right? Please go through that. Try to recall what you had studied over there. Try to write a code, not just seeing that. That is not enough, right? And I'm stressing this. Try to write a code by yourself. Is pretty important. Okay, so we don't have much time, right? You need to work on this, right? So the next thing, right? The next thing is I'll directly jump into a loop, right? If condition is over, that's very important for us. I have demonstrated 2 types of codes over there. One is simply if there is no else, simply I can return some. Then if else if, that is also possible, right? So the next one is I'm going to use what is called as a for loop. Okay, to demonstrate the for loop, right? Let me create a list now. Okay, so let me create a list, right? So I'll try to demonstrate not just a for loop here, but also how to skip a count, right? And how to break out of the for. Everything I'll try to show you here. Okay, so what I do, I'll try to define a function. Okay, so this is the function. Okay, define add list, and I'm passing n to that. So don't worry about this, right? Even if you don't write that, it is going to work. Okay, so I just have to pass an n to that. So this says that what you are passing, you are passing a int, you are passing a list. So this is actually says that I'm passing a list, and the return is also an integer. Return value is an integer. It's actually suggesting that. So don't worry. Even if you don't write, the program will work. I initialize the sum equal to 0. Okay, so this is the n, right? This is the n. See, the for loop is very easy compared to the other languages. For example, if you look at say any other language, you have to start from for I equal to 0, I is less than n, I plus plus, something like that you have to do. Now you see it is for I in n. What is n? Now you look at this n. N is nothing but this my list. This list, in this list, I in n, in the sense it understands for every I, whatever is I should be a element from this list, is what it says. In the sense, I will be automatically understood what it is and automatically taken one by one, starting from 2, then 8, then none, then 3, then 7. One by one it will come. That's what is a loop, right? So it will be done automatically. For I in n, so now you see I'm using if condition. If I is a none, I cannot add that because my intention is to find the sum of the elements in this list. So can you add a none to your answer? No. So you skip it by saying continue. If at all the I you see in the list is none, continue. Continue means go to the next one. Okay. I will put another condition here saying that, right? When I ask you a question, look at this. This is the question. Now I am forming the question. Add the elements of a list to find the elements, and right, you have to come out of that. You don't have to add if at all you encounter a number which is greater than or equal to 10. So in the sense, starting from 2, 8, etc., you keep on adding, right? None comes, you continue, you skip that, go to 3, go to 7, go to none, skip that. When you come to 23, you have to come out saying that it is more than 10. Okay, so what do? Look at this. I put another condition. If I is greater than 10, break. So look at 2 very important aspects of looping structure. One is continue, You are based on certain condition, you can skip the current loop and go to the next part. Okay, next iteration, that's possible. But that's happening when you use continue. But if you use a break, you are completely coming out of this loop. You are not going to do any more calculation in that loop. In the sense, 23, though you have a number 6 after that or 100 after that, it will be removed. It will not be considered. Okay, right? You are not going to loop over that part of your data. Okay, so understand here. So this is advanced to the next iteration by using continue. This is used for exiting the loop. So if none of this will happen, my sum is equal to my sum plus I. In the sense, 2 will be added, 8 will be added, none skip, 3 will be added, 7 will be added. Once again, none will be skipped. 23, if for I in n, if I is greater than this thing, it will break. Break means it will come out of this and it will simply return whatever is the sum that is existing till then. Okay, so what's the answer that you expect when I call this, when I pass my list to this function? It is simply addition of 2 plus 8. Sorry. So this is 2 plus 8 plus 3 plus 7. That's all. So 20 is what I'm expecting. All right, let's check. Right. So add list is my function. I'm calling this add list my list. See, 20. Okay, so this is what we were expecting. Yes, we are getting the answer. Okay, I hope that is fine. Okay, right. Now let's go for another part. Okay, so that is the while loop. Okay, right. Any doubt with the for loop or anything with the continue break statement? Please let me ask. Please ask me. Okay, otherwise let me. Okay, let me go for it. Okay, that's good. Right. So the next part is actually while loop. Right. While is something. While will be used. I'll tell you when to use while. For you are going to use when you know how many times you are going to repeat. Like I know that I have to repeat something 100 times. So in such case, you will go for the for. But when I don't know how many times, right? But I know a condition, right? But I don't know how many times it's going to repeat, you will go for a while. So you see, whenever n is greater than 0, I repeat this. But I don't know how many times n will be, whether n will be less than 0, greater than 0, or whatever is the condition, that actually depends upon what is there inside this. Okay, so this is how it works. Now I start from right. I pass a number to this function. I am trying to take a sum. Whenever that n is greater than 0, I check that the sum is greater than 1000, or if that is greater than 1000, I break out. I'm adding something. If the sum becomes more than 1000, I come. Okay. So if that is not the case, my sum is equal to my sum plus n, right? N is added to the my sum. Whatever is the previously present my sum, you are adding on to that. And next you see n becomes n half of that. N is equal to n divided by 2, right? So that is actually you are taking only the integer part out of it. Okay, so like this it repeats, right? And you get an answer. So how many times this repeats, how many times this loop repeats, dependent on what is the n value you enter. Correct? So basically you see, I don't know how many times it is going to. But in the previous case, I was very sure I am supposed to repeat the loop maximum. That is the length of your length of the data which you have. It was a list, right? So length is the number of elements in that list. Maximum is that. That's why you told for I in n. You know that that's the limit. That's the maximum number of times you are going to repeat. But here you see that's not a case. Okay. So in this case, it has to be right unknown parameter, but there is a condition. So as far as that condition is met, you will do the math. Okay, you will execute the. Okay, so let's try to do that. So find sum of let me write 500. So 994, because it satisfies the condition greater than 1000 means you come out. So right, as soon as this becomes greater than 1000, came out. So before that, the highest answer you got is 994. So it actually shows that. Okay, so this is a demonstration of what is called as a while loop. Okay, then very important, one more parameter we have. Okay, so that is actually called as a pass. Okay, you can pass something. You cannot, you don't want to do any calculation. You simply want to skip something. It's some in a loop. It can, you can consider that as a continue. You don't want to do anything, go to the next one. But here you see, so I'm actually defining plus or minus. Okay, I just want to see whether entered number is positive or negative. Okay, so whenever x entered is positive, right, it comes here, x greater than 0, it prints positive, it returns positive. If x is less than 0, it returns negative. But whenever x equal to 0, I am saying pass, do nothing, simply leave it. It means it will not even print anything. Okay, I'll show you, because I'm not saying print or I'm not saying anything, I'm simply say pass. So if I call the plus or minus of say 0, see, nothing comes. At the same time, if you ask plus or minus of 100, it is positive. Okay, so the plus or minus of minus 9, it's negative. Okay, only when you give 0, it passes that value out, it skips that, it's not going to do anything. Is it fine? I hope, right, you are fine with this. Okay, let's go to some of the inbuilt functions which are widely used in Python. Okay, so the first one is called as the range function. Okay, very important, range 10, right? It creates a range, right? What is there inside this? If you want to see, you have to go for the print. Other than, if you don't enter print, it will, if you just check what is there, it simply prints that one. Okay, so what I do, it's print the range of 10. Now you see, this is how it is. Oh, still it is printing. Then I have to go to a list. Sorry, my mistake. It's a list of range of 10. Yeah, okay. So you are able to see that what is there. It actually creates all the numbers starting from 0 till that number. That number which you enter is exclusive. 10 means you are printing 10 numbers starting from 0. So that will be 0 to 9. 10 is excluded. Okay. So this is the first thing. Then let me go for, I have an option from where to, now you see, simply called range mean it will start from 0, goes to some number and it's stops. But you have a facility to specify from where to start and where to end and what is the increment you want. You see the increment is 1 here, default 0, next number is 1, next number 2, next number 4 and so on. Now you see, this is what I want to generate. So list of range of, right, I will start from 2. I want to go with the say 43 and I want to increment this with 3. Right? 3 increment. Let's see. So 2 then plus 3, that is 5 plus 3, like that. You see the last number is 41. If you add 3 to that, it exceeds the 43. So it's not being printed. Okay, so that's the usage. I'll also give another example. List of range of, you see now I am starting from 31. Okay, I am going till -4. Okay, and decrement by -6. Will it work? Yes. So 31 decrement, how much from that? So reduce 6 from that, -6. -6 is the step. So -4 is the last number I want to see, right? So before that, the satisfying condition, whichever number that satisfies this, is 1. Okay, so 1 from 1, if you subtract 6, it becomes -5, which is outside your range of -4. That's why that is not included. Okay, so that is what is called as the range. Range creates a series of numbers, but you have to represent that in any of the formats. So I used list over here. Okay, so list is that. Okay, so any doubt with this, please let me know. All right, so then let's move further. right? We have seen the range function. Range is one very important. Other one I'll touch that slightly later. Okay, so let me go ahead and let me discuss something else. What are the other data structures? What are the very important data structures we have? Okay, so that's what I'm going to start with now. So the first one I'm going to discuss here is called as a tuple, right? So tuple is, right, fixed length, immutable sequence, right? It's a sequence of numbers. List is also sequence of numbers, but that is mutable. You can change that. Okay, so here the length is fixed. That is the first feature, and it is immutable. Those are the two things. So how to create them? Very simple. You don't have to use any bracket. Simply keep entering the numbers. So my tuple is equal to 1, 2, 3, 4, 5. Okay, a tuple is created. So print my tuple. So see, it's not using the square bracket. It automatically uses a parenthesis. Okay, so type my tuple. You see that, right? It is a tuple. Then, right, actually there is a complex way, right, in which you can generate the tuples. That is called as the nested tuple. It's a tuple inside a tuple. In the sense, instead of writing a element like 1 here, that 1 has to be replaced by a different tuple itself. That is possible. Okay, so I'll try to show that how to create them, right? This is important. This is used many cases, right? You will see that. That's why I'm stressing that. Okay, so my nested tuple is equal to, this is how I create. Okay, 1 comma say 2, okay, comma, this is 3 comma 4 comma 5, then 1 1 comma 2 2 comma 2 3 comma 4 4. All right, so I'll try to look at that minus a tuple. You see here, right? So this is the first entry, which itself is a tuple, right? It's called as a nested tuple. So this kind of arrangement is what is called as a nested tuple. Okay, so that's one thing. Then again, we can write a code to access this and all that will be there, right? Anyway, we are going to deal that at a later stage if time permits. If time does not permit, anyway, you will find the details in the material which you are going to get at the end of the day. Okay, please go through that. Then I want you to teach something like, okay, I have a list. I want to convert a list into tuple. That's very important. We will be seeing that many times. So the tuple is a keyword. Okay, tuple of, inside the bracket you enter a list. The list gets converted into a tuple. For example, right, you can pass the name of the list, or you can simply enter the list 1 1 2 2 3 3 4 4, etc. Right. So see the answer. This is no more square bracket. It's a parenthesis. So that means it is nothing but, right, it's nothing but right, you can see, right, we have uh, the list getting converted into a tuple. Okay, all right. Now already we know that we cannot do what is called as we cannot alter this, right? In the sense, we cannot remove something and we cannot modify that. In the sense, I cannot remove this 3 4 5 completely, and right, I cannot do something like that. Okay, so that is not possible, right? So it is mutable. It's immutable, right? So it's not a mutable case, it is immutable, right? So that is one thing. Okay, there is another very important feature that is required. How do you read these elements, right? From the tuple, I want to take out its elements. Means it is called as unpacking the tuple. Okay, so let me create a tuple first so that I can unpack. Okay, so my tuple 2 is equal to, let me write 11. Maybe I'll add a Hello. So you understand that anything you can put over. It's not required that everything should be of the same data type. Okay, so I have a number, integer, I have a string. Next, I'm going to put a list over here, and I also want to show you that you can put true or false. Okay, true. Okay, so you understand that this is a tuple. Okay, now, right, I know that there are four elements. I can actually extract them to different variables. So w comma x comma y comma z is equal to, simply write the tuple name. This is my tuple 2. Okay, so just look at this. W, what is W? You see 11. What is X? It is hello. Okay, what is Y? That is 2, 3. What is Z? So, right, the each elements of the tuple gets extracted, right? We call it as the unpacking, right? Unpacking of a tuple. In the sense, elements of a tuple are getting extracted. Okay, right. Now, right? So, what is the major advantage of tuple? Again, I'm not going in very depth now, right? But I'll tell you one very interesting feature, right? Which I have never seen in any other programming languages. Okay, so very interesting. That's why I'm touching this. So let's try to create m uh, comma n equal to say 3 comma 5. So this is valid statement. So if you check this, m becomes equal to 3 and n becomes equal to 5. Okay. Now I'm asking a question to you. This is a question. I give you 30 seconds to think. You can type, you can check that, and you can give me an. Okay, so that is also valid. My statement is m comma n equal to n comma n. Okay, so I repeat, I'm trying to make an entry like this. Okay, this is the quiz of this particular session. So everybody has to answer this. Okay, so what happens? You type, right? Whatever you think is your answer, you type it. Yes. Okay. So I hope you tested this and you gave the answer. Okay, right? Because your answer is right. Now you check m becomes 5 and n becomes 3. So m and n values swap. So swapping becomes very simple. Okay, recall what you used to do in C program if you have to swap something, correct? So that becomes very easy, right? This is what is uh, very interesting, right, about this. All right, then let's say, let me check what else we have here. Okay, tuples are done. I'll directly jump into the list. Okay, so anyway, let's try to create I already have a tuple with me. Okay, how to convert a tuple into list? It's by now you should remember that. Okay, so I think let me create a tuple first. All right, so that is. Uh, let me check what is there in my tuple. My tuple is this. Okay, so list of my tuple. In the sense, I'm converting a list. Sorry, tuple into list. This is very interesting, very important. Okay, uh, but the advantage is that you cannot change these values. I cannot say 5, I cannot replace 5 by some other number, but here you can replace that. That's the fundamental advantage. Okay, and the difference, right? So then, right, if you want to add an element, right, we can do, right, something like append. There is a method called append. Okay, so let me call this is my list. Let me check what is there in my list. My list is this. Okay, okay, my list dot, there is what is called as append. You can add something to this, right? So you can add by, right, let's check this. My list dot append, check this. So you see, right, compared to this, we have added one particular element at the end, right, in this particular answer. right? So that is the first thing, right? Another very interesting function is this, the mylist dot insert, right? I have to specify where I want to insert. Now you see at this position, I want to insert. In a sense, this 8 should be shifted to right. Okay, so that position is 1. And I will insert hello to that. Okay, so just check this now. My list. See, the 8 onwards, whatever you have, they are still there. They are moved to right. And we created a position over there and we inserted whatever we want to insert. That is hello. All right, so that's one thing. Then I can also perform what is called as a pop. Okay, removing an element from this. So that is my list dot pop. I just have to specify what I want to pop it out, which position index I want to pop it out. Let me say I want to remove this none. Okay, so starting from first position, the position of this none is 0, 1, 2, 3. So I just entered 3 here. Okay, check out my list. Now you see there is no none. The first none has been removed. Okay, so 3 came to the previous position, 7 came to its previous position, and so on. Okay, and elements can be removed if you know the value. Like for example, hello, I know that there is a hello in my list and I can remove it. Okay, so this is how you do that. This is something like my list dot, I think we have remove. Yeah, so there is something called as remove. Specify what you want to remove. So I will say hello. Okay, sorry. What's happening? Wait a second. Yeah, all right, so now you check the my list. See, hello is being removed. So you know the value, you know the what you're supposed to remove, enter it directly, right, in the remove. But you don't know what value it is, but you know where it is, what is the location, right? You just use the pop. Okay, two things are there. Then you can actually check whether a number is present in your list or not. So for example, 2 in my list. You can say that yes, true, 2 is present over there. Okay, also you can do, let's say, what you can do. Okay, there is another option called the extend, right? So my list dot extend, in the sense towards the end you want to add something to this. Okay, so extend, I want to add another list to this. So the list contains true, and I will add a say tuple 22, 33. Let's check this. Okay, now you print my list. See, it was only till Dhaarini Academy, correct? So that is already present. Whatever was there is we have here. To that we extended something. Is it okay? So this is how it gets extended, right? Then okay, let me create another list now. So let me create my list is equal to 12, 6, 3, 66, 84, 25, 10. All right, so this is the one. Normally we want to perform a sorting. Okay, so my list dot sort, simply call this, it gets sorted. All right, and now you check my list. See, this is the one very interesting and very important feature. Okay, so just remember, there is, with respect to a list, always you have a sorting operation. What are the other operations supported by list? You can check my list dot tab, right? Append, clear, copy, count, extend, right? Everything you can see here, right? So just check that, and you go through this and you understand each and everything over here, right? How did I come to this? Type the list name, that is my list dot tab. Okay, initially we discussed, if even if you don't remember, okay, follow this, right? Okay, then Now I can see sometimes this is another scenario where we know that there is a number right in my list, but I don't know where is it located. Okay, so that's the most common thing what we face normally. Okay, so that this is how you can solve that issue. Okay, uh, it's actually called as bisect dot bisect. You just have to tell what is the name of the list. It's my list, comma, I just have to tell right which is the number that you want to okay, so bisect is, sorry, my mistake. I started with the bisect. I'll go with the bisect, then I'll go to the position. Okay, now I have a list with me, and let me say that I want to insert a number to this list. This is a sorted list. Okay, this is already a sorted list. You can just see that on the screen. Line number 158 says that it is a sorted list. Now, if I want to put 9 into this sorted list, which position I'm supposed to put is my question. To answer that, I'm trying to use a bisect. Bisect dot bisect my list, comma 9, because 9 is the one which I want to insert into this, right? You see it. Sorry, what happened? Bisect dot bisect, it says bisect is not defined. Okay, sorry, my mistake again. It's completely my mistake. I apologize. I have to import, right? So import bisect. Now the problem will be solved. Okay, then I paste, right? See, it says position number, index number 2, starting from 0. So where is 0? 0 is this, 3 is 0, this is 1, this is 2. So 10 has to be, before 10 it has to be there, means 10 has to move forward further and put 9 over there. That's what is the usage. Very important, we are going to use it. Okay, that's why I'm stressing this out, right? Try to understand what bisect dot bisect is going to do. Okay, and then another thing is that is actually directly insert something on, that is actually called as bisect dot insert, right? It will put the value to the list in such a way that it keeps sorted. Okay, it keeps in the sorted form. Like I know that 9 has to be put into the position 2 so that it keeps it's still sorted. Okay, I'm trying to do that. My list, comma 9, right? So insert, right, this comma 9, right? So I'll check the my list now. Let's see. So compare this. So 10, 12, they have been moved to the right and created a space for 9 so that 9 comes between 3, 6 and 10 onwards. So between 6 and 10, there is a space created so that the list is still in the sorted form. Okay, so this is pretty much important, right? So that's what I want you to understand. Okay, let's do this once again. The bisect dot insert my list, comma, I want to add 55. Okay, my list, just check that. Okay, 55 came between 25 and 66, saying that this is the place, this is the suitable place for 55, so that you keep your list still in the sorted form. Okay, I have a data set, something comes up, I want to keep it at a particular position so that my list is not going to be altered. This is the application, right? We will be using this in machine learning, deep learning, data science, etc., many other fields. All right, so that's the importance. Okay, so coming to the next part of the list, the important objective for us is called as a slicing. You take a piece out of it. Okay, for example, my list of, I want to start from the index number 2 and I want to go till the 6th, means you will put 7 over. Okay, 2 to 7 means my list 0, 1, 2, 3, 4, 5, 6, 7. Okay, my mistake. Sorry. Again, typing error. I made a mistake here. Not 2, comma 7. The column starting from 2, go till 7. So 2, that 2 to 7, 3 to 5. So that 2 which you write in the middle right is indicated by the column here. Sorry, that was my mistake. Please see that. So this is second one, second, third, fourth, fifth, sixth. Okay, seventh one is not included. Whatever you write as a last number, that is not included. 7 is written there, so seventh one is not coming. Okay, only till here it comes. Okay, so these are the 2, 3, 4, 5 indices. 2, 3, 4, 5, 6. Is it okay? Now this is useful, right? You can even make use this to make some changes. Okay, so something like, right, I can make the change such as my list of 2 column 3 is equal to, I can actually add a list in this position, 11 comma say 11 comma maybe I can put 15. Let's see what happens, right? So I'll go to my list and just see here. So this is the my list which I'm talking about. In this I'm trying to make some modifications. So position number 2, right, I have to put 11 and 15. So position number 2 in the sense 0, 1, 2. So 9 will be removed. Okay, and in the position of 9 I'm going to put 11 and 15. Okay, the rest of the terms are as it is. 10 to 84 you still have. Okay, so you, in the sense, the idea is that you can use this slicing to put something to the particular location in the, instead of the slice, you can put something else in that position. Okay, so this is what is the usage, right? Now there is a very interesting feature that is available in the Python to address the last number, because I don't know what is my last number. I don't know what is the length of a particular, what you call, list. When I don't know the list size, right, I cannot access the last one. I may have any other approach like finding out what is the length, right, and using that as an index, right? But there is a very easy thing here. My list of, simply put -1. Just see what happens. So this is index 0. This is index 1, right? This is index 2. This is index 3, and so on. When you have 0 here, right, when you take a -1, it actually goes to the last position. This is -1. This is -2. This is -3. This is -4. Negative indexing is allowed. So what I do, I'll check the same concept once again. My list, I'll say -3. See, that is 55. Like this is -1, -2, -3. So negative indexing is also allowed and it is also possible, right? Use it appropriately, use it wisely whenever required. Don't say that I'm stuck, I don't know how to go ahead because I wanted to go to the last 3, last 4 or something, right? Build the logic, right? So that you can do this. Okay, very important, very interesting, right? You'll see the programs that are written in such a way that, right? Normally, when we try to apply the conventional method, we'll never understand that, okay, this can also be done. But when you see somebody has written a very wisely, the code is written very wisely, means they'll use everything which is supported by the Python. Okay, so very important. Take some practice. Okay, initially I cannot expect everyone to do that kind of coding, but yes. Now I'll tell you something. I'll show you something more. My list, I'll try to slice it in such a way that starting from all till all, then I'll write 2. In the sense, increment by 2, 2. So see this. The first one will be printed. Then the 6 is skipped. 11 will be printed. Then 15 is skipped. 10 is printed. Then 12 is skipped. This is sliced. 66 is sliced. So that's what is here. In the sense, right, this is the notation saying that starting till end, right, 2, 2 at a time. You can go for 3, 3 at a time, 5 at a time, etc., depending upon what you wish to do. Okay. All right. Then we'll have another very interesting thing, that I have a list with me. Okay. I have a complete list available with me. But what I want to do is that I want to keep a track of okay, zeroth index this one, first index this one, second index this one. That is also I want to hold, right? I simply don't want to hold a series of numbers in a list. I also want to hold what is called as index corresponding to each of the entry in the list. Okay, so that is possible by using a built-in function called as enumerate. Okay, so that is what is called as a enumerate. Let me try to show you that. Okay, so this is how we do that, right? Let me try to create a list now. So my list, I think I already have a my list. Okay, let me update that. My list is equal to, let me try to write a, okay, so let me create something like this. Okay, this is my list, but now my intention is that I want to keep track of zeroth index is A, first index is B, second index is C. Automatically I don't want to write a program saying that, okay, go to the first position, whatever is there, put along with 0, whatever is in the second function, put it along with the 1, etc. I don't want to. Okay, so enumerate is a function which is used, widely used. Just remember, this is going to come many times. Okay, so for index for I, B for the value, I comma B in, right, enumerate of whatever list. I think the list name is my list. Okay, my list is the what you call, is the variable which I am passing to this. Okay, so in this print, right, I, then I want to print with a, oh, okay, this is a character, so I have to put a this thing and comma B. Just see what's going to happen, right? That's very wonderful. Enumerate creates something like index value for each and every element that is present in the list. That's all. Okay, I'm trying to find that out and I'm printing it out. All right. So that is one very interesting feature. And another function which we are going to use we are going to use it regularly. Okay, so that is what I'm going to call it as the zip function. Okay, so there is what is called as a zip function. Let me create another list for that, just to demonstrate. Okay, I already have my list with me, that is equal to this. I'll also write my list, say 2. My list 2 is equal to, that is mm, comma a. All right, so this is the next list. Now you see, I'm going to use the zip. The zip is the one which is used to convert uh, two lists all together into a tuple, right? Because I have two different lists present. I want to convert them into a tuple, right? Individually, you can convert into a tuple. How do you do that? You know that. Okay, but this is how I do it. Okay, so I call it as zip is equal to, simply call zip of the my list comma my list 2. Okay, and make it a list to visualize that. Okay, list of the zip. You see, what happened? My list is AABB. What happened? Something changed. My this is my list, right? So see the difference. I made a mistake. This has to be my list, capital. So now you see the difference. Okay, whatever I write here, the first position will be collected from the first list, that is AA, and the first list is MM. So AA and MM are clubbed together to form a tuple. This is the zipped tuple. Okay, so then BBB is actually aligned with NNN, that is your second tuple. Okay, you are converting a list of tuples and you're printing it out. So this is another very important feature, which I'm going to call it as a zip. Okay, so right, very interesting. Okay, any doubt with this so far? Any doubt you have, please ask. Otherwise, let's go further. Good. Okay. So let's move further. So the next concept is a dictionary. I think you have studied the dictionary part as well. So how to create a dictionary? You can create a dictionary by, right, what we call as a, right, the flower brackets, curly braces, right? So that is equal to this. You have to have what is called as a key and a value. Key value, like that it is supposed to be given. You have to use a colon in the middle, in between the key and the value. Okay, so this is how you write. If the key can be a text or character, so A is my key, I'll say that the value is text, text one, maybe. That's the first one. So this is the key value pair. After that you put a comma. Okay, then immediately after that I'm going to enter my next this thing. So I can write, say, PVB, right? Then the value could be 1 2 3 4, anything, any mixture, anything you want, you can create it. That's what I want to show. All right, so then I have the next one, which is, say, 10, and the value is 2000. Okay, so my dict is what I want to print. So this is what is the case. Okay, type of my dict. So that is a dictionary, right? So this kind of is called as a dictionary, right? So we have, right, various options over there, right? Like based on what you call as the key, right? I can actually identify something from this. Okay, so let's say, let me try to add something to this. How do you add something to the dictionary? I'm going to check that first. Okay, so that is my dict. Oh, so A is the first one, in the index is 0. The BBB is the second element, index is 1. 10 is the third element, which has an index, sorry, 0 1 2. So I will go further. Okay, so 0 1 2 I already have. Then I'll address with the key. Okay, the key is nothing but, I'll say, 3. So 3 is my key, and in this key position equal to 3, supposed to put, say, 1 1 comma 2 2 comma none. Let me see. Let me check what happens with this. Okay, my dict is what I want to do. Now you see, it whatever you said here, right? That is a third one. It's actually 3 refers to the key, right? Not a position. It's a key, right? So key is equal to 3. In for 3, it actually adds a list there, which is 11 comma 22 comma none. Okay, so it will not be in any order, it will not be in any sorted order, because key does not mean that it is an index. Key is not an index. Key is just a value to identify the elements of uh, the values of that particular key. Okay, so in this fashion you can actually enter the values over there, right? I can actually check. If you want to check what is present, I can simply check like this: my dict of, so enter a key value A. So you see it is text one. So A is what I'm going to ask for. It generates an answer like what is the value of that. If I ask my dict of 10, it will say the answer is to 2000. Okay, right. So the next important part is delete. Okay, so I just have to use del my dict. Oh, it's del. That's why it was not showing. My dict of, tell which key you want to delete. If I say delete 10, 10 and 2000 will be deleted. Okay, so I just specify 10, so that will be deleted. Check my dict. So the 10 and 2000 is eliminated. All right, so that's one option. Other option is a pop. Okay, my dict dot pop. Okay, pop, you just have to tell the key which you want to pop out. That will take out this text one from that, right? And you can see that if you enter my dict, that is not there in the list. Okay, so that's how it is, right? Then I can actually check what are the various keys present and what are the values present, because using the keys you are addressing the dictionary, right? So my dict dot keys. Okay, sorry, my dict dot the keys, you have to call it as a function, so that it will show you that okay, at present there are two keys in the dictionary. Whenever a new dictionary is given to you, you can check that by using this. So also my dict supports not only just keys, it also tells you what are the values. Okay, you can check it in this way, right? It says that so BBB is a key and it holds the value 1 2 3 4. 3 is the next key which holds the values. It's a list containing 1 1 2 2 and none. Okay, so that's pretty important and pretty interesting as well. All right, so then okay, then let me check what else we can discuss, right? Very important things only I'll be able to discuss here. Okay, so look at the dictionary part as well. All right, then the next important data type is called as a set. Okay, so look at this set of set of, say, I'll write some numbers and observe that and try to guess what will be the result. 1 1 comma 2 2 3 3 comma 1 1 comma 4 4 comma 5 5 comma 2 2 comma 3 3. Okay, so the idea is that you need to you need to recall the set theory, right, which you have studied. So let me try to my set equal. So I just want to show you what is the data type. That's why I have assigned that to a set, a variable called my set. Okay, now I run this, and if you print my set, you see that only 1 1 2 2 3 3 4 4 5 5, which are the unique values entered, right? In this list, only the unique values are extracted and put it over there. That is what is the characteristic of list, right? List does not contain the repetition, right? For example, when I say that I toss a coin, what are the possible results? You will write a set over there saying that h comma t. You will not write h comma t comma h comma t comma t comma h comma, because you might have tossed that several times, right? But you will write out only what are the possibilities out of that, correct? So out of my 100 tossings, only two possibilities. One is h, one is t. So what are the possibilities? If I ask a question, you will write a set over. So same thing is going to be performed over here. That is what is called as a set. So when I say I'm creating a set, let me show you that it's actually a completely different data type here. Type of my set. Let's see, it is a set. That's all. It simply creates a set, right? So whenever you perform a set, our Python supports union, intersection, etc. Many other operations are also supported. Okay, everything you studied in a set theory is definitely supported here, right? Just check how to proceed with that, because right, that somewhat may be important. So that's why I'm not writing it down here. But remember, there is what is called as a set, and you are supposed to look at the various options that are present over there. Okay, right? So what are the various options? You are supposed to check that as well. Very important. Right. Then we need to go to a very important part. This is the last topic we are going to discuss today, and we'll be stopping after that. This concept is what is called as list comprehension, right? List comprehension is something like you are trying to generate a new list from the existing list based on three operations. First operation is called as a mapping operation. Second operation is called as a filtering operation. Third operation is called as a reducing operation. So three fundamental operations of list comprehension. Very important. This is most widely used way to make your code very compact. Instead of writing 10 lines of code, you can do the same thing if you use either mapping, reducing, or filtering. Three operations. Any one of them, if you use your code, 10 lines of code, all of a sudden cut short into one line. That's what is the capacity. That's what is the power. Okay. So let me try to do something here. Okay. So this is what I'm going to call as a mapping operation, right? I'll try to do this. So let me first create a function, right? So define the squaring function, and I'm going to pass a number n to that. Okay, so I simply return whatever n comes, right? Simply raise it by power. Okay, simply raise it by power 2, n power 2. This is what I'm supposed to return. And n comes, 2 comes there, 2 square, 4 should be returned. That's all. Okay, so this is what is my function. Very simple. Now what I do, I'll try to create something like this. Okay, so I'm trying to create a list of, see, this is what is mapping. I'm mapping something to a list. So map, what you want to map? I want to map this function. Which is this function? This function indicates the function which I'm talking about right now. That function, right? And that function is, right? What is that function? It's the squaring function which I'm using. Okay. So that is a squaring. I think I called it by FUNF. No problem. Squaring function. No, right? In the sense, create a list. To every element of this list, you apply the squaring function. That's all. Okay. So I create that. It's a range. I know that range of. I simply write 10. Okay. So just see the result. What is this range 10? Let me show you the range 10 also. Range, oh, sorry. I need to make a list, right? To visualize. Just see this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each of them is actually passed to this function. 0 square is what? Is 0. Next 1 square is 1. Next number 2 square, 4. Next number 3 square, 4 square, 5 square, 6 square. Like that, all the numbers. See, that is what is mapping. I have a list here. That is 0 to 9. I have a function here. So this function is made to pass through this so that every number is applied by this particular function, that is squaring function, and you get a different list as answer. So this is mapping a function to each and every element of a list is called as a mapping. Very, very easy, very interesting, very simple, right? Nothing complicated. Okay, so just understand. All right, so that is what is called as a mapping, right? Refer to the material that is going to come today, and you will get a lot of examples for this. Okay, over there, right? And then you have another representation for that. Okay, so that example is also there in that. I'm not going to touch that. Okay, the next part is called as a filter. All right, so the filter, I'll try to write it in using a different function. Okay, I'll try to define a different function over here. So define num select. Okay, select a number. SELECT, num select. Right, I'll try to select a number from whatever that comes into this. I'll pass it as an n. Okay, and return n percentage 3 equal to, oh sorry, not minus, equal to 0. That's my first case. Or n percentage 5 equal to 0. Now you know what I am trying to do here, right? I am trying to select a number if number is divisible by 3 or number is divisible by 5. Okay, only those numbers are what I am saying that I am returning from this particular function. Okay, so let me run this, and now you see what I am trying to do. List of, now you see I am not applying map. I don't want to select the numbers which are all the numbers from a list. I want to select those numbers which are satisfying this condition. Condition is either divisible by 3 or divisible by 5. So for applying that, I'm going to call filter. See, the previous one was map. Every number in a list needs to be square. But now it is not that case. I'm applying a condition to the filter. I'm applying a filter or a condition to the list to pick up certain numbers from there. Okay, so that's what is this. So filter of, tell which function. The function is num select. And apply this to the range of numbers starting from 0 till 60. Okay. See, 0 is divisible by both. 3 is divisible by 3. 5 is divisible by 5. Next number is 6 because it is divisible by which number? Divisible by 3. Next number is 9. That is divisible by 3. 10 comes into picture because this range of 16 is what? Range of 16, if you see, it's all the numbers from, oh, sorry, my mistake. I always keep forgetting to make a list here because I want to visualize means I have to go to a list. Okay. All right. So see, this is what I'm passing. There is a function, filtering function. To this, I'm passing the numbers 0 to 16. But output of this filter is only these numbers. So you are actually filtering it out. You know what is a filter, right? So why do you put filter to the water faucet? Because you want to filter it out, right? Filter the water. Whatever passes through the holes of that filter, you want to catch it. You want to hold it. Others, you don't want to catch. That's what is happening here. That's why the name is called as the filter. Okay, right? So that is right. Another function. Right now, okay, right? So let's say that I want to, right? I want to go for the last option, right? That is called as a reduce option, right? So this is another function, define adding function, right? I will pass two things here. One is A and one more is B. Okay, two things I'm going to pass. So return simply A plus B. This is what I'm trying to do. But where I'm applying this is what is important, and how I am applying this is important. Okay, so just listen to this. I'll create a my list. Let me check what is there already. If it is there in the my list, I'm going to use it. Okay, I think it's not enough. So let me create a list now. So my list is equal to 1, 2, 3, 4, 5. Let's say. Okay, so this is my list, and I'm going to apply a different type of function. So two types of functions we already have seen. One is a filter and one is map, right? There is another thing called as a reduce. But if you want to apply that reduce, you have to bring it somewhere from somewhere. That is import what is called as func tools. Yeah, import func tools. From there I can use it. Okay. The func tools dot reduce. Just see now what's going to happen. I have to pass a function and I have to pass a list to that. What is the function? The function is add function. Okay, and I'll pass my list. Okay, my list. See the result. It is nothing but addition of each of the term present in that list. Each of the element of the list. So the idea is this. I have a list here. Okay, I have a list. And I have a function. This function applies on each and every element and reduces the whole list into a single number. That such as addition. Addition is what? Addition is something. You pass a A, you pass a B. A is a, right? Two numbers will be passed to that. So element by element, this will be iteratively processed. So first two numbers, 1 plus 2, result is 3. To the 3, next 3 is added. So 3 plus 3 is 6. 6 plus 4, 10. 10 plus 5 is 15. So you see here, this whole list will be added together to get a number 15. So again, this is just a function which I apply. Okay, you can create your own, what you call, your own way, right? You can think in your own way to, right, to apply this, what you call reduce function to get, right, a result which can be applied to a complete list and getting a single answer out of it. Okay, so three types of list comprehensions are pretty important, right? Right, all the three will be used widely in our application. Okay, so in addition to this, in our study material, you also have set comprehension. What are the things you can do on the sets, right? And you also have dict comprehension, which is nothing but that's going to apply the comprehensions which we have studied now on the dictionaries. Okay, so that's going to come, right? Then some simple examples of functions are, okay, I want you to go through them in a detailed fashion, so that, right, you understand everything. All right, so that's the fundamental idea we have here, right? And at the end, you can see that a lot of what you call examples are, exercises are there, right? You can try to, right, understand that, and you can try to solve it. Okay, so mostly I will be continuing from this point in the upcoming session, right? We will be discussing about the functions because that is very important. We have now discussed that. So we'll touch the functions part first. Then we will look into a special type of functions called as lambda functions. Those are the very basic functions, very basic types of functions we will be able to write. Okay, so that is actually important, right? So, right. Meanwhile, I want you to go through this content plus the one which I'm going to send, right? So that thing. And towards the end of that document, you will see exercises. Okay, so question is there, and as well as the answer is given there. I want you to type, right? See that, type by yourself, get adjusted to that, how this is written, how the functions are going to be running, etc. I want you to see, right? So that I want you to come back with doubt in the next